All right, today we're jumping straight into an investment briefing. We are going to break down a really critical decision, one that has a direct line to your yield and profitability in any kind of high-purity manufacturing. We're looking at a risk that could be costing you millions. So let's just start with a number that should get your attention: $1 million. The data we're looking at shows this is the potential cost of a single contamination event on just one lot of 300-millimeter wafers. It's a staggering figure, and it really underscores just how sensitive modern manufacturing has become. So that brings us to the big question, right? What if this massive financial risk isn't some rare freak accident? What if it's hiding in plain sight, right inside the standard automation equipment that you rely on every single day? Is this just an accepted cost of doing business, or is it a huge, unmanaged liability? Okay, let's dive in. We're going to start with a diagnosis. We're going to pinpoint the exact source of this incredibly expensive problem. And it turns out it often comes from the workhorse of industrial automation, just your standard pneumatics. You know, what's so powerful about this quote is how specific it is. An FRL, that's just a basic filter regulator lubricator, is a standard piece of equipment. But a single one, if it's not perfect, can pump out enough oil mist to be absolutely catastrophic for cleanroom operations. And it doesn't matter if you're making semiconductors or pharmaceuticals, the result is the same: disaster. So how does this actually happen? Well, your standard pneumatics are introducing contaminants in three main ways. First up, you've got mechanical wear and friction. Every single time a cylinder actuates, its seals and bushings are shedding microscopic particles. Second, lubricant contamination. That oil mist we just talked about gets sprayed into the air. And third, the exhaust air itself becomes a delivery system, carrying all those wear particles and oil directly into your clean environment. All right, so we've diagnosed the problem. Now let's talk about the solution. And this isn't about trying to put a Band-Aid on a flawed system. It's about investing in an entirely different class of technology: cleanroom certified pneumatics. And look, this is not a minor upgrade we're talking about. It is a fundamental redesign from the ground up. We're talking about specialized materials, like fluoropolymer seals that just don't shed particles. It means a completely oil-free operation, using special fluorine grease that's applied just once during assembly. The exhaust is controlled with point-of-use filters, and the components themselves, they're built and packaged in a clean room environment to begin with. Now, let's be totally transparent about the upfront cost, because yes, there is a premium. Cleanroom certified pneumatics can have an initial price tag that's 1.5 to 3 times higher than their standard counterparts. But as we're about to see, that initial number, it's only a tiny fraction of the real financial story. And that brings us to the most important part of this briefing: the return on investment. We're going to do a total cost of ownership analysis because this is where the business case becomes absolutely crystal clear. Okay, take a look at this table. The story it tells is just dramatic. In the scenario from our source material, the initial investment for standard pneumatics is $40,000 versus $65,000 for the cleanroom version. Okay, but now look at the annual impact. The standard parts are tied to a jaw-dropping $12.5 million in yield loss, plus another $300,000 in downtime. The cleanroom parts? A tiny fraction of that. The total annual financial hit for the cheaper option is over $12 million. And if that table didn't make it clear enough, this chart says it all. That towering red bar, that's the total annual cost impact of using standard pneumatics. And that little green bar next to it, that's the impact with cleanroom pneumatics. The ongoing costs of contamination and downtime absolutely dwarfs that initial difference in price. It's not even close. So let's just put a final number on that. In this particular manufacturing scenario, making the switch translates to a net annual savings of over $12 million. That is not a typo. It is the real-world difference between constantly fighting defects and running a stable, predictable, high-yield operation. So what does that mean for the payback period? The extra investment here was only $25,000. By preventing even a tiny fraction of that multi-million-dollar yield loss, the payback period on that investment is less than a single day. I mean, honestly, you are unlikely to ever see a more compelling financial justification for a capital equipment decision. So you see, this data completely reframes the decision. This is not about buying a slightly more expensive component. This is a strategic business case. It's about mitigating risk, it's about protecting revenue, and it's about guaranteeing operational stability. And really, it all boils down to this choice right here. What are you actually choosing? On one hand, standard pneumatics represent an ongoing operational liability.
They're a source of hidden costs and unpredictable yield loss. But on the other hand, cleanroom pneumatics are a strategic asset. They are an investment in yield protection, in uptime, and in compliance.
And that brings us to the final question, the one you should be asking back at your own facility. When you look at your automation equipment, what do you see? Do you see an asset that's enabling your business, or do you see a hidden liability that's quietly eating away at your bottom line? The answer to that question directly impacts your yield, your compliance, and ultimately your profitability.